Okay, section 7.4, similarity in right triangles. In a right triangle, the altitude to the hypotenuse yields 3 similar triangles. Okay, let's first talk about the altitude. So the altitude divides the right triangle. So keep in mind, this is just for right triangles. The altitude divides the right triangle into 2 smaller triangles that are similar to the original triangle and to each other. So, moral of the story here is that we end up with 3 similar triangles, and they overlap each other. Okay? And so we're going to use that strategy we've been using all along of pulling those 3 triangles apart and just drawing them separately and then comparing them. It makes it a little bit easier. It's very overwhelming to look at it drawn as 3 triangles all overlapping each other. Let's talk about an altitude because we need to know what that is. Okay, an altitude is a segment that connects the vertex angle and the opposite side forming perpendicular lines and right angles. Perpendicular lines form right angles. Okay, so I'm going to give you an example of this in a second. Let's label this giant triangle. These are right triangles, so we're going to put a right angle in here. This is going to be angle A, and this is going to be angle B, and this is going to be angle C. Okay. The altitude is the segment that connects the vertex angle to the opposite side. This segment that I'm drawing in right now is our altitude. Okay, and we're going to call this point down here D. So up here as an example of an altitude, BD is the altitude. Okay, BD is the altitude. It makes a perpendicular line with the opposite side, so it creates a right angle at the bottom. So we have 3 triangles here. I suggest, and like I usually do, to kind of separate them. So we're going to look at this triangle first, and we call this one the small triangle. Okay, I'm going to put it over here. A, D, B. Right? We know that this is a right angle. Okay? So as you can see, we have angle A and angle A, which are exactly the same. They have to correspond to each other. It's as though they sit one on top of the other. I could take the small triangle and put it right back over there, and they would sit right one on top of the other. Okay? So that's what we have so far. Then we have let me see, in this awkward pink color, we have this triangle on the right hand side, and I'll put this one over here. So even if I put it back, we have this right triangle. So it forms a right angle. This is D, C, and B. And you can see the angle C corresponds with angle C over here. Okay? And then in green, we have the large triangle that we were talking about at the beginning. So 3 triangles you can see here, 3 different colors. And I'll just put the large triangle straight down here. So we have this very large triangle. Okay, A, this is the right angle, B, and this is C over here. Okay, and we had angle A had 1 bar, angle C had 2 bars. So already I can see that there are some comparisons among my 3 triangles. My small triangle, that's this guy. We'll call this one the small one. My medium triangle, that's this guy. And my large triangle, that's this guy. So we have those 3 triangles. So we're sort of not really paying any attention to this overlap now. We're just going to kind of look at the 3 individual triangles. And we can see that they're similar to each other by angle. Okay? They all have 1 bar and a right angle. 1 bar and a right angle. 1 bar would have to go here, right? It would have to, because this is already 2 and corresponds to C. So this would have to be 1 bar. So you can place that in here. When you look at your small triangle, it has the 1 bar and the right angle. It just needs to have the 2 bar placed in. So you put that one in up here. And now all 3 of those triangles are complete with all their markings. What's really cool about it now is that they're all similar to each other and all of their sides are corresponding to each other. So just below your picture, we're actually going to compare what sides go with what sides. So we can see that we have AB corresponds to AB. So right angle, 1 mark, right angle, 1 mark. So AB, this one, corresponds to this one. And then when you think about all the hypotenuses, this is a hypotenuse. It's across from your right angle. And it corresponds with this, which is also your right angle, which corresponds with this, which is also your right angle. So these are all corresponding sides. Let's mark them. Hypotenuse, hypotenuse, hypotenuse. All the hypotenuses have been marked, okay? Let's mark all the sides that have 1 bar and a right angle. So I'm starting in my small triangle. 1 bar and a right angle, those 2. Go to the large triangle, 1 bar and the right angle, those. And then the last triangle, 1 bar and the right angle, those. And then the third sides would be the sides that are between the 2 bars and the right angle. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? Corresponding sides, corresponding angles. So beneath it, where it says corresponding sides and corresponding angles, okay, we're going to go ahead and mark these. All right. So I'm going to move this up. And we're going to mark this. So underneath here, corresponding sides, corresponding angles. So I know my picture's not there anymore, but you know what it said. So we have side AB, okay? It corresponds with, in the large triangle, the hypotenuse, which is side AC. So we have an AB, we have a side AC. Well, I won't say similar. We'll just make them in commas. These are the ones that are all corresponding to each other. So we had AB, we have AC, and we had, in the last one, BC. Those were all of our hypotenuses. Okay? Then we had all of the sides that were between 1 mark and the right angle. Okay, so 1 mark and the right angle, we had AD. And AD is similar to 1 bar and the right angle, BD. And that is similar to, in the large triangle, 1 bar and the right angle, and that would be AB. Okay? And then the third corresponding sides are the sides that were between 2 marks and the right angle. So we have BD, and in the medium triangle, between 2 bars and the right angle was DC. And in the large triangle, between 2 bars and the right angle was BC. Okay? Corresponding angles, pretty simple, right? We have all the angle A's that correspond to each other. We have all the angle C's that correspond to each other. And then we had all of the right angles that correspond to each other. All right, let's practice this. Let's move on to the next page. So again, I'm going to scroll up, and we're going to actually just put this into practice so it'll make a little more sense. I'm going to give you a couple of examples here in this particular picture, and we're going to finish the statement. Okay? So again, before I do this problem, I'm going to tear them all apart. I'm going to do this little medium triangle over here. So I have S, and I have H, and I have B, and then I have this little tiny triangle over here. So I have A, and I have H, and I have R, and these are my right angles. And then I have my large triangle here with my right angle up here, and then I have A, B, and C. All right? And obviously these have to correspond to each other because they both sit here. And then these have to correspond to each other because they both sit here, right? And they all have their right angle, so the only thing missing in this triangle is 1 bar here, and the only one missing in this triangle is 2 bars here. So now I'm going to make my comparisons. R is to H. So R is to H. Now I'm telling you that you can't use the same 2 letters from the same triangle. That's a huge no-no. So if I'm using R, I can't use the H that's in its triangle. I have to find H somewhere else. So I'm talking R is to H, right angle and 2 bars, is to H, right angle and 2 bars. And then they say as H is to, and so again, if they're using H a second time, then they're not using the one they've already used one time. So now they're using a different H. So you go find your other H. Here it is. It's between the right angle and 1. And we have to go back to the triangle we're using. So we're really not using the middle triangle right now, the big one in the middle. We're using the 2 side triangles. R is to H, those are in red, as H is to what in that second triangle? So I need to find the side that corresponds with it that's between 1 mark and a right angle. This is the side that is between the right angle and 1 mark. So your answer here is S. Okay? Let's ignore those colors and we'll start again. C is to A. Again, can't use the same triangle, so I can't do C is to A in that middle triangle. I have to say C in the middle triangle is to A in the triangle off to the right. They do have the same markings, so that does mean that they're corresponding to each other. As A is to, so I went C is to A this direction, as A is to what in that direction. So what corresponds with A? So between the right angle and 2 marks. So the side between the right angle and 2 marks is R. Okay? In number 3, I'm just going to read this backwards. I'm going to read it as B is to S as what is to B, so that I can make my comparison first, right? B is to S, so find B and S. And we can't use them this way in the same triangle, so we have to say B is to S as what over here corresponds to B over there. So B is between 1 and 2. I find the side that is between 1 and 2, and that is C. And then the last one, S is to B. So now we're going in this direction. S is to B as C is to what? S is to B as C is to what? All right, so this is going to be a really tough one. S is to B as C is to what? So C is marked here is to what in this triangle? So 1, 2, 1, 2. B. Okay. If you had difficulty with that, please make sure you speak to one or the other of us so we can go over that with you before you move on. All right, a geometric mean. It is the proportions in which the means are equal to each other. Okay, so first of all, you need to know what the means are, right? So a geometric mean uses what's called the means extremes property. AB is equal to CD. So they take a proportion, and they're saying that the means are equal to each other. So this is considered what we call the means, and this is considered the extremes. So the means extremes property, okay? If they're saying that the means are equal to each other, they're saying that one of your cross products is going to be equal to each other. It doesn't matter whether it is A and D or whether it is B and C. Even though they have a proper name, means and extremes, you can you can flip them back and forth, so they're commutative, so to speak. So basically they're just saying one of your cross products has to be the same. So if they want you to find the geometric mean, they do want you to cross multiply. They want you to find the geometric mean between 4 and 18. So I need 4 numbers to fill in my fractions, to fill in my proportion. And I know that 2 of those numbers is going to be 4 and 18 because they gave them to me right from the problem. They want the geometric mean between 4 and 18. So what you need to do with the other 2 spaces is make sure that they are the same, equal, the same to each other or the same as each other. So let's put our variables in there. That's the mean, right? The mean has to be the same, and that's what we're solving for. So let's just call the mean x and then put it in the equation. Anytime you're doing a geometric mean, you're going to have one of your cross products be the same. If the geometric mean is what you're searching for, then put x's in there. How do you solve this? You cross multiply just like we always do. X times x equals 4 times 18. You need to be really careful with x times x. It is not 2 of them. You're not adding them. You're not doubling them. You're multiplying them times each other. That is x squared equals 4 times 18, which is 72. And then you undo a square by taking the square root. So we're going to square root x squared. And if you square root one side of the equation to get rid of it, then you have to, because these are inverses, so you get rid of them, you have to square root the other side. So the square root of 72, do that on your calculator, 8.5. There's your geometric mean. So now the question is, find the geometric mean between 4 and 9. So you're going to have x is to 4 and 9 is to x, because these have to be the same. X squared equals 36. Take the square root of x squared. Take the square root of 36, and x equals 6. Okay. Square root x is to 4 as 12 is to x. X squared equals 48. Again, take the square root of x squared and the square root of 48. X equals 6.9. That one does not come out even. That's a decimal. So over here I have 6 and I have 6.9. And then the last one, x is to 5 as 125 is to x. So we get x squared equals 625. When you take the square root of x squared, you get x. When you take the square root of 625, you get 25. So the answer here is 25. Okay? Awesome. All right, we're going to move on and figure out how am I going to solve these equations using this information. So we're moving on to the next page. Let's do that. Oh, we're going to start here first, using the proportions. Let's do this to solve. Okay, so we're going to actually use these triangles to figure out how to solve for x. So again, I always like to take them apart. So I have this little triangle that has 4 and 6. This is my right angle. And then you have to figure out which of the 3 triangles you have enough information for. So that's this little guy. Okay. My big triangle has a right angle here. I have no information about this side. So I don't have anything for the left. I don't know any information about the right-hand side, but I do know the x plus 4 is the length of the bottom. Okay, so that's the big triangle. And then the triangle off to the left-hand side has the x down here. Okay, has x here and has 6 here. So after you've broken them apart and labeled all the pieces that you know, you decide which of the 3 triangles you're not going to use. And I'm not going to use this triangle, and the reason is it only has one piece of information, so I can't set up a proportion. So now I'm just going to concentrate on my 2 smaller triangles. X in this triangle is between the markings with a right angle and 1, and so in this triangle that would be this side, because this one already has 2 markings because these 2 angles have to be congruent. That means this one's going to be the one with 1 marking. This is going to be the one with 2 markings in my other triangle. These 2 sides have the same marking, right angle and 2 marks, and now it's just a matter of setting it up. Okay, so x in the left is to 6 at the right, and so x is to 6 as 6 is to 4. 4x equals 36. You're going to take that and divide both sides by 4, and 36 divided by 4 is 9. Okay? Second example, same situation. I need to break it apart. So I'm going to have 3 triangles. I'm going to have this one. Okay, these guys are the same, and this is my right angle, so I have 10, and I have x, so that's going to be my double. I have this triangle over here with 40, and then this is going to be 2 markings, which leaves 1 here, and then this is x, and then I have my very large triangle. Okay, so this is my right angle, 1, 2, the whole bottom is 50. I don't know anything about the right-hand side, and I don't know anything about the left-hand side, so this triangle is the one that I'm going to eliminate because I don't have enough information. Let's color code the other side. 1 bar and a right angle, 1 bar and a right angle. So if I decided to go in this direction, I would say x is to 10 as, color code this side, x is between 2 bars and the right angle, 2 bars and the right angle. So remember, I'm going in this direction. So then I'm going to say 40 is to x. And then I'm going to cross multiply. I have a mean, a geometric mean. X squared equals 10 times 40 is 400. You take the square root of a perfect square to eliminate it and get x by itself. If you square root one side of the equation, you square root the other, and the square root of 400 is 20. Last problem. Scoot the page up and see if we can get this last problem done. Same deal. Let's redraw our triangles. Okay, so there's my right angle, 1 mark over here. So this is going to be the 2. I have a 9, an x, and a y. This triangle over here, I have a z, a y, and a 7. So if that's my 1, this is going to be the 2, which means I have to put a 1 up here. And then my right triangle in the middle, there's my right angle. Okay, I have x over here, I have z over here, and then the bottom is the total between 9 and 7, and that's how I get 16 for the bottom of my big triangle. Okay, 1 mark here, 2 marks here. Now what I'm trying to do is solve for my variables. Okay, so I have to decide which of my triangles I'm going to use. So I'm going to do the first problem in red, which is where I'm solving for x. Okay, and so I have to use the 2 triangles that have x's in them. So x is 2. So I find in this next triangle that also has an x in it, what side corresponds with that? 1 and 2 markings. So x is to 16 as, and then I have to figure out what is to x because I'm trying to solve for x. So x in this, so I'm going in this direction. X is to 16 as what in this left triangle is to x in the right triangle. So you have to find what markings does x have. It's between the right angle and 1. So 9 is between the right angle and 1. So x is to 16. This one, x, is to 16 as 9 is to x. And then you cross multiply. X squared equals 144. Square root both sides. And x is 12. Okay, first one's done. Now in blue, let's solve for y. And since I'm solving for y and the 2 outside edge triangles have y in them, I'm going to do these 2. Y is to, find the matching markings. Y is to 7 as what in the left triangle is to y in the right. So find the markings and then find its corresponding side, 9. 9 is to y. So look at your picture. Y is to 7 as 9 is to y. Again, we have a geometric mean. Y squared is equal to 63. Square root both sides. And y equals 7.9. All right, let's do the last one. You should see a pattern happening here, I hope, that we're having geometric means occur. So the idea is that perhaps we'll do that again. Now I'm looking for the triangles with z's in them. So z is to 7. Z is to 7. Those have the same marks. As what is to z? So 16 is the side that has the same markings as z. And I did it right because I have my geometric mean happening. Z squared equals 7 times 16, which is 112. Square root both sides. And z equals 10.6. That is your lesson on similar right triangles.